Alright, welcome back. This is part 2 to the MLife. I'm actually splicing these two videos together because I actually forgot to mention something that's kind of important in the last video. Okay, so this 806 kilonewtons includes blade weight. So how do we know what the weight of the blade is, or the mass of the blade? Well, if you go back to your original 5 megawatt land DLL wind turbine folder, you look for this one called elastidine.sum or ed.sum and right click, edit with notepad. You're going to look somewhere around line 54ish, actually 53. Mass of blade 1, 17,536 and some change. So take mass, times it by gravity, you'll get an answer back in newtons. So it turns out it's about 172 kilonewtons. So, with that in mind, this is what kind of my thinking of how I do things. So we have 806 minus 172. So this is the amount of load, just force itself, loads from external things, not blade weight. 634 kilonewtons. Now, remember the max load to last 20 years is 806, but we now need to include our factor of safety. So, usually a factor of safety for a wind turbine is 1.5, so I'm going to divide it by 1.5. Tells us it's 422.6, so I'm going to round up to 423. That means if we want these blades to survive, withstand, stay around for 20 years, at least 20 years, then we should not subject them to more than 423 kilonewtons of force their entire lifetime. Now, we can't guarantee that because you never know when a hurricane is going to come through. You never know when a turbulent wind is going to come through. Now, this is at 12.5 meters per second average wind speed, which is roughly 27 miles an hour. Usually, most wind farms are geared for 12 miles per hour annual wind. It's about 4 meters per second. So keep that into consideration. Now this is just at faster winds, so not bad. Okay, so that's including the factor of safety. Now, if you wanted to, you could, those are just external loads, so you wouldn't want to subject that. But if you add, I just got to think. Now here comes the tricky part. Do we add in the 172 or do we subtract the 172 from this value? It's a great question. So I'll let you guys decide that. But for me, I've already subtracted it out, so I'm just looking at it as purely external loading should only be the 422.6. If I add in the weight of the blade, I wouldn't want my external loading to be more than 250 to 300 kilonewtons. So that way I can be extra safe. But, you know, all practicality. Anyway, I just wanted to show you guys how to get the mass of the blade, where to find that, and then how to keep that into consideration when you're doing your calculations. Anyways, thank you for watching, and good luck.